Let's do a correlation. So you can see I've got up here books correlation.sav, just a simple little correlation where we have two variables. We have ID, doesn't really count, but we have books and GPA. And if I expand the label here, you can read what that is. So this is just hypothetical data to say that, maybe the number of books a kid read in 5th grade is somehow related to that person's high school GPA all those years later. So we're going to go ahead and test and see if that correlation is there. Just quick, let me go ahead and head to the data view. You can see we've got 30 data points here where we have number of books in this column and GPA in the other. And let's go ahead and just test the correlation. So analyze, we're going to go to that analyze menu we know so well, down to correlate, and then bivariate. Bivariate meaning we're looking at the correlations between two variables. Bivariate, two variables. You might remember it that way. So let's go ahead and click bivariate, and I can go ahead and move each of the variables of interest over here into the variables window. Okay, here it's really easy because there's really only two options available, so I went ahead and put them over here in the variables window. You could do more than two at a time, and it'll just compare the correlation for each possible pairing of variables, but for here it's going to be real easy because we just have the two to work with. And that is it. We're going to go ahead and stick with two-tailed. This checkbox down here, flag significant correlations, is really helpful. So we'll get a little set of stars next to significant correlations. It'll be easier to spot, especially if you have a bunch of things you're testing a correlation between. And we're going to go ahead and leave Pearson's on as the correlation coefficient. There are different ways to do a correlation. Pearson, though, is pretty darn popular. And we just click OK. And it's as easy as that. So here we can see pretty plainly that there's a significant correlation between the number of books that a person read in 5th grade and their high school GPA. Specifically, we can see that the R, the correlation coefficient, is 0.478. Okay, so in terms of the standards for effect sizes, that's a large correlation. It's close to 0.5, so we'd call it a large, strong correlation. And even though we only have 30 people in this sample, you can see the significance level is 0.008. Okay, so we say that we have an R, a correlation of 0.479, and a P of 0.008, which means if it's less than 0.05, if that's our cutoff, that we found a significant relationship here. And that's pretty much it. You can see also that there are two little stars next to 0.478 that indicates it's significant. You can see the legend down here underneath the table saying that the correlation is significant at the 0.01 level if it gets 2 stars. If it only got 1 star, then it would be between 0.05 and 0.01. So just an easy way to spot correlations that are significant there. Before we leave this, I just want to show you how to plot a scatter plot, which is a way of visualizing this correlation, right? To see overall, are these two variables related to each other? We know statistically they are, but what does it look like? So let's go ahead up to the Graphs menu, choose Chart Builder, and you can see I already have it set up here. Let me reset it just to show you where things come from. Right here down in this lower left corner of the chart builder, you can see all the different kinds of charts that we can use. And we're going to stick to the scatter/dot plot. Okay, and all we're going to do is a simple scatter plot. So we're just going to take that first option and drag it into the main window. That gives us the starting point. And then we can really choose to put either of these variables on either of the axes. But usually you want to think about it, what do we think predicts the other one, right? What's the outcome we're interested in, and what's the input that we're interested in? So I think here it's the most sensible to ask, is number of books on the x-axis, is that a strong predictor of high school GPA, right? So what we're predicting is on the y, and what we are using to predict it is on the x. And that is all. Hit OK, and you can see your scatter plot arrive. So here you can see pretty clearly each of these points is one of the 30 people in the study, and it corresponds to 2 pieces of information. So if you look all the way down here, this is someone who read maybe looks like 1 or 2 books in 5th grade and has a 1.0 GPA, right? That's one single person. Right? But overall, there's a pattern here where as the number of books that someone read in 5th grade goes up, GPA seems to go up as well. Right? Maybe not a perfect relationship, but it's definitely there, and there's something interesting to be found. Okay, so we take all those dots and we do the correlation, and that's how we get this information up here. Right? So it's standardized as the relationship between these two variables. Okay, and that's all it takes to do a correlation. It's pretty darn simple. And like I said, you could put a lot of different variables into that window, and it'll spit out every correlation between every combination of variables. But you have to be careful because you don't want to test too many of them because you risk having a huge type 1 error. But it gives you a simple way to do a handful at a time. Okay, so go have fun.